All right, for this video, we're doing proportion test. So we've introduced just the idea and concept of a hypothesis test, just in brief, and I'm going to do this next section for proportion test as an example problem to kind of walk through all the steps that we go through when doing a proportion test. So the first thing you have to identify is that it's a proportion test. So in this case, it says the national average is that 50% of high school students have never smoked. All right, so when we're looking at that, looking at and saying, okay, 50%, oftentimes that 50% is an indicator that this is a proportion test. All right, all right. But really what you're looking at when you're doing this is asking yourself, what are my variables? In this case, the variable is they have never smoked or they have smoked. There's only two possible outcomes, so this is a proportion scenario. So as soon as I do that, then I can go, all right, so when I'm doing this, I'm going to look and see, and then just start going through the process of doing a significance test. I know I'm doing a significance test because I asked the question, does this evidence support my claim? So my claim is what I'm trying to prove. So I look back in this question and I say, well, what am I trying to prove? I wonder if this is accurate. It's a very subtle way of asking the question, but we're asking the question, is the national average 50%? Or is it not 50%? And that gets me to my two hypotheses. My two hypotheses then are P is equal to 0.5. And again, remember, when doing a hypothesis test, it's always a parameter. So I'm going to either be using, this is just notes on the side, it'll either be P for a proportion. You could use pi if you're talking about a proportion. You could be doing a test for mu if it's talking about an average. So again, these are the same thing, pi and P. All right. Is it mu for an average? And in some rare cases, you may be asked to say, testing for variability, in which case you would write the letter sigma. All right. But in this case, it's a proportion, so I'm going to use P. And my null hypothesis is always equals. And it's equal to 0.5 because that's what the claim is. They said the status quo, the national average, what it always has been is 0.5. And I'm wondering, is that accurate? Is it accurate or is it wrong? If it's wrong, then it would be not equal to 0.5. So I'm doing what's called a two-sided hypothesis test. One for greater than 0.5. Sorry, yeah, one for greater than 0.5 or less than 0.5 because that's what it means to be not equal to. Could be too big, could be too small. All I know is it's just not equal to, all right? So that's always step one, is write your hypotheses. Step two is to verify conditions. So verifying conditions in the way our book says it is the state, plan, do, conclude. This is the plan portion. So I go, okay, S. S is SRS. Is this a simple random sample? And if I look back up here, it says I randomly sampled. SRS is stated. Independence, just like we did when we did confidence intervals, we have to show that n is at least 10n. That is, let's see, so 10 times 75 is 750. Safe to assume there are over 750 teens. Therefore, independent. All right. So n, capital N is greater than 10n. So 10 times 75 is 750. Safe to assume there are over 750 teens, therefore independent. You need to write that all down. You cannot just skip steps and write any less than what I'm writing. N is my normality question. All right. When we're doing a binomial, or in this case a proportion test, NP is my number of successes. So in this case, NP is, 47. That came right out of the reading, 47. All right, which is greater than or equal to 10. NQ is the number of failures. So in this case, that would be people who do smoke. So 75 minus 47 is 28, if I'm subtracting correctly, which is also greater than or equal to 10. Therefore, sampling with an ing distribution of p hats is normal. All right, and that's huge. You got to write that. You got to say something about the sampling distribution of p hats. And therefore, it's normal. And then S is sigma. Sigma is the standard deviation, and nowhere in this problem did they tell me the standard deviation. However, with a proportion test, this is only true for a proportion test, sigma is known because capital N is greater than or equal to 10n. All right, my population is over 10 times my sample size. All right, that's only true when doing a proportion test. So sigma sub p hat is equal to PQ over N square rooted. And that's right off of your formula chart, folks. Got to use your formula chart. Know that it's all there. You don't have to memorize everything. That's not the expectation of this class or this test. So when you're doing this next section here, that's the number that we're going to use for the standard deviation of the statistic, or for p hat. All right. So here I just did a whole bunch of work all in a row, but let me walk you through it. First things first, I drew a normal curve. All right, I'll just trace that there. I drew the normal curve. Here it is. And I drew the normal curve because I was told that the sampling distribution is normal for all p hats. And I shaded both ends because this is a two-sided test, because it's not equal to over here for the alternative hypothesis. So it's two-tailed. And then I write down the formula for doing a significance test. Sorry, I'm mumbling my words right now. And that is Z equals p hat minus p divided by square root of pq over n. From your formula sheet, it's statistic minus parameter divided by standard deviation of statistic. And then I plug in numbers. My statistic is 47 over 75, because that was my sample, minus 0.5, that was my parameter, that was my p from my null hypothesis. And then the denominator is pq over n is my sample size 75. Now if I did my calculations correctly, and you should verify this, and if it's wrong, please put the correct number in the reflection response. But check my math on this. I did it on my cell phone, which I never like doing. I like using my graphing calculator. All right, and then I find out that if I use the z-table, let me look at my z-table for 2.20. Now if it's a different number, you'll have to tell me what that is. But 2.20 is 0.0139. So this area right here is 0.0139. All right. But I'm positive. Sorry. So I'm positive. So that's the top end. But when I started out doing this question, I didn't say I think it's more. I didn't think I said I think it's less. I just said I think it's not accurate, that it's different. So when I'm doing my final analysis, I need to do and take into account both ends, because even though it was larger, 47 out of 75 is larger, I didn't know that it would be larger. I just thought that it would be different than 0.5. All right. So I'm going to get rid of that. I'm going to get rid of this. I'm going to get rid of that work. And then I'm going to see if, I have to get rid of this here too. So finally, I need to make a conclusion. So after I did my calculations, that was this. And I found out that the likelihood in that area was 0.0139. I need to make a conclusion. What does that mean? What does that tell me? This is what it tells me. Since results as different as these, the 47 out of 47 out of 75, they could only happen 2.78% of the time. by the way, in your reflection response, write where that number came from. Where did the 2.78 come from? I'm not just making up numbers as I go. Maybe you have to go back and rewind and watch a little bit, but figure out where did that number come from. All right. Since results as different as these could only occur 2.78% of the time by chance, this is significant statistical evidence to prove that the proportion of teens who say they have never smoked is not 50%. This, my friends, is a necessary thing to say. You need to say all of that top portion when you're working on a problem. All right. Then I say, therefore, I reject the null and I accept the alternative hypothesis. All right. Rule of thumb. Whenever that probability, in this case 2.78, whenever that probability is less than 5%, I'm going to reject the null. If they do not give me a level of significance to test against, I will use the 5% level. Now, what if they had said using the 1% level of significance? Then I would say I cannot reject the null. I do not accept the alternative. And since, even though this only happens 2.78% of the time, it's not enough statistical evidence to prove that the proportion of teens who say they have never smoked is 50%. You see, the difference in how I phrase them isn't that much different. It's just a matter of where you put the word not in there and say there either is or is not significant statistical evidence, but you got to say why. That's the thing. Don't just say there is or there isn't, but you got to explain why. Since 2.78% is less than 5%, boom. Or if they had given us a level of significance of 1%, I'd say since 2.78% is greater than 1%, then I cannot prove the alternative. You have to give an explanation. You cannot just say answers. You need to back it up with the numbers and show that you understand how they relate. I gave you several things to write in your reflection response. Hopefully you got them all figured out. I believe I said maybe 2, maybe 3 things in this video. Get that done, and I'll see you in class.